Today in this video lecture, we will see some important concept related to this chapter 3 of torsion. First important term is polar sectional modulus. Second, strength of a shaft. Third, torsional stiffness. Fourth, torsional flexibility. Fifth, torsional rigidity. And last is power transmitted by shaft. So, we see first polar sectional modulus. This polar sectional modulus is defined as the quantity which is obtained by the polar moment of inertia of the cross section of the member by the distance of extreme fiber from centroidal axis. We will first write this definition and see equation for solid shaft and hollow shaft. Write definition polar sectional modulus. Sorry for handwriting because of this new pen tab. So see first term polar sectional modulus. Polar sectional modulus is defined as the quantity which is obtained the polar moment of inertia of the cross section of the member by the distance of extreme fiber from the centroidal axis. Polar sectional modulus is defined as the quantity which is obtained by the polar moment of inertia of the cross section of the member by the distance of extreme fiber from centroidal axis, and this polar moment of inertia is denoted as Zp is equal to J polar moment of inertia denoted as J and divided by distance of extreme fiber from centroidal axis. Distance of extreme fiber from centroidal axis is R, capital R. This is polar sectional modulus is denoted as Zp and SI unit is mm cube. Unit of this polar sectional modulus is mm cube. And for solid shaft, this polar sectional modulus is polar moment of inertia for solid shaft is pi d raised to 4 upon 32. So here J is pi d raised to 4 upon 32 and divided by R is distance of extreme fiber from the centroidal axis, and this extreme distance of extreme fiber from the centroidal axis is d by 2. R is diameter by 2. So here pi d raised to 4 upon 32 multiply by 2 by d, small d, is equal to this pi d raised to 4 is also in small. This d is also in small. Because we have considered for solid shaft. This is solid shaft of diameter d, small d, and polar moment of inertia for this solid shaft of diameter small d is pi small d raised to 4 upon 32, and radius is diameter by 2. And here pi d cube upon 16. This is solid shaft polar sectional modulus pi d cube upon 16. Similarly, for hollow shaft, polar sectional modulus is Zp is equal to J upon R. And polar moment of inertia for hollow shaft is, this is hollow shaft. This inner portion is hollow. Outer diameter as capital D and inner diameter as small d. So polar moment of inertia here pi by 32 into capital D raised to 4 minus small d raised to 4 divided by radius is this capital D divided by 2. So this equation so this polar sorry so this polar sectional modulus for hollow shaft Zp is equal to pi upon 16d, this 2 this 16. Next term is strength of a shaft. The ability of a shaft to resist the action of twisting movement is called as strength of a shaft. The strength of a shaft is the ability of a shaft to resist the action of twisting movement. It's called as strength of a shaft. This is action of twisting movement, and to resist this action of twisting movement, ability of a shaft to resist this action of twisting movement is called strength of a shaft. So this is shaft. Circular, let us consider circular shaft. And this is longitudinal axis. This is twisting movement T. This is twisting movement T. This twisting movement resisted by this shaft, and resistance is the ability of a shaft. Okay, so this is strength of a shaft, and it is given by formula for this is T is equal to tau into ZP. So this is strength of a shaft is equal to shear stress multiplied by polar sectional modulus. Next term is torsional stiffness. Torsional stiffness is the torque required to produce unit angle of twist. Required torque to produce unit angle of twist is torsional stiffness. Required torque. Why this required torque? Because of we have to produce unit angle of twist. It is the torque required to produce unit angle of twist is torsional stiffness, and equation for this is torsional stiffness is equal to G into J upon L. This G is sectional modulus. Sorry, this G is shear modulus or modulus of rigidity. And this J is polar moment of inertia. And L is length of a shaft. Torsional stiffness is equal to capital G into capital J upon L. This capital G is modulus of rigidity or shear modulus. J is polar moment of inertia upon L is length of a shaft. And SI unit is Newton meter per radian. Next, torsional flexibility. Torsional flexibility is opposite to this torsional stiffness. So, torsional flexibility is equal to 1 upon torsional stiffness. See, it is the angle of twist to produce by unit torque applied. Unit torque, and it is the torque required to produce unit angle of twist. The difference between here in torsional stiffness we use unit angle word, and in torsional flexibility we use unit torque word. Torsional flexibility is equal to 1 upon torsional stiffness. And this torsional stiffness is Gj upon L. Therefore, L upon Gj is torsional flexibility. Next term is torsional rigidity. Torsional rigidity denoted as capital K, and it is the product of modulus of rigidity and polar moment of inertia. These are all technical terms related to chapter 3 torsion. Modulus of rigidity is capital G and polar moment of inertia, capital J. And SI unit is Newton meter square. And equation is K is equal to torsional rigidity is equal to modulus of rigidity multiplied by polar moment of inertia. modulus of rigidity, capital G. And last technical term is power transmitted by shaft. Power transmitted by shaft, it is the product of average torque and corresponding angle turn per unit duration of time. That means power is equal to average torque multiplied by angle of rotation. Like this technical term, power transmitted by shaft. Sorry for handwriting and noise disturbance. Power transmitted by shaft, it is the product of average torque and corresponding angle turn per unit duration of time. Power is equal to average torque multiplied by angle of rotation per seconds. P is equal to average torque multiplied by, and this average torque is denoted as capital T multiplied by 2 pi n upon 60. So this P is equal to 2 pi nt upon 60. And unit is watt. And this T means average mean torque in Newton meter, and N is number of revolution per minute. So those are all some technical terms related to torsion. Thank you very much.